Hello there and welcome to my workshop, and today the results are in on the next big project that I'm going to carry out. It was a 60-40 split, so what I've actually decided to do is carry out both builds, that is to convert the big manual mill to a CNC mill and make a relatively large CNC router, but I've elected to build a half sheet or a 4 foot by 4 foot working bed area, which is 1200 by 1200 in millimeters, and 250 millimeters in Z height, because I want to be able to get, you know, a log underneath it and machine something into a log. However, I've needed to make a few variations from what I originally said on, I think, a video about a month ago regarding the CNC router build, which will be the first build. You know, this is going to take me probably 12 months to do the both conversions, you know. But the 60% of you wanted larger CNC router, so that's what I'm going to be doing first. In fact, I've already started ordering main parts for it. And we'll come to that in a second or two. Now, the variations that I have made was to, I think quite a number of you out there sort of took a step back, I think, when I said, about $3,500, and I think some of you are still finding that a little bit too steep. So what I've done is I am going to make the best possible CNC router that I can and I've set myself a budget of $2,500, and I'm pretty sure I can come pretty close to that. It's going to be $100 either way. So, the design, I'm in the middle of design process at the moment, and I'm, like I say, I have ordered some parts already, and I'll show you now in a sec. But of course I had to make some variations. Now, the variations were, and quite a number of you were sending me emails saying about, was it necessary to go NEMA 34 closed loop steppers into the servo drive? And of course it's not. It's not totally necessary. I mean, if you was building a machine for a business, then I would probably encourage you to go to NEMA 34s and servo drives. But for home use, and sort of semi-industrial use, I suppose, as well, because it's not worth building something if it isn't going to last the course. So what I've done is I'm designing it for NEMA 24's high output. Okay, high torque, high output NEMA 24s, and I'm using 4 of them. Or should I say 2 driving the y-axis, and then 1 for the Z, 1 for the X. And they're very high output. And I'll show you now. I'll zoom into the screen a little bit more so you can see it rather than me. Okay, so I've decided to, sort of, like I say, build the best possible robust 12x12, we'll call it, or 4 foot by 4 foot CNC router that I possibly can for $2,500. And now I could have used linear round rail, but that would have meant me going to 25mm bars, and I'm sort of looking at the cost of those, and it puts me right up in line with square linear rails at 20mm. So I've elected to go linear square rails, and what I do is I, as much as I can, buy local stock, providing shall we say they come close to overseas stock, if you get what I mean. I sort of turned to linear square rails because A, they're about the same cost as 25mm round bar linear glides, and B, these tend to be, shall we say, a little better at holding tolerance. Although linear round rails are okay, these are a little better. And the profile, when they're put together, is much lower. Because if I was going to use 25mm diameter rails, that means the overall height, by the time you take in the bearing and the linear rail and the support, it'd be between 75 and 80mm. Well, this is less than 50mm. So I'm sort of losing sort of height there, which is good, which is what you want. Otherwise, when it comes to something like the Z-axis, it's going to be standing right out, away from the gantry. So these are a better all-rounder. So that's what we're going with. It's going to be 20mm. It's measured across this way. 20mm square linear rails on all axes. So there's going to be 2, not 4. So there's going to be 2 on the Y, 2 on the X, and 2 on the Z. Okay, so the next thing to choose is the threaded rod or zero backlash ball nut and screw. I like to buy them now in a kit form because I mean, before I used to sort of make my own bearing blocks and buy bearings locally, but by the time I did that, it was ending up costing me 3 times as what these can be supplied for. So that is what I'm doing. I'm buying it as a kit, and again, local stock. I think you can save a bit by buying local stock. They're going to be SFU's 1605s. Now that means 16mm in diameter and 5mm. Okay, each revolution, 1 turn, is going to progress the nut 5mm. Now that's roughly what is that? About 3/16, I think. 3/16 of an inch for all you working in Imperial. But these are sold in metric. You can sort of work it. It's very, very easy to work out how many revolutions or steps of the motor needs to go to move an inch even. It's fairly simple process to do. Okay, so 1605s. Next up, Gantry. Now, you know, you can make gantry out of a lot of things, and you know, steel is really probably too heavy. I was conscious of the weight, because you know, you need the y-axis to, you know, move a lot of weight, come to a stop and turn and come back, and it's that takes the high peak of the torque output of your motors. So, you know, in an effort to keep the weight down a bit, I've gone with this is 80 by 160. All right, 80 millimeters is what, 3.5 inches, just under 3.5 inches across there, and oh, let's see, 160 is just a six and a quarter, nearly 6.5 inches along that way. This is the standard type of aluminium extrusion. It's actually called 80 by 160. So if you're looking for it, just put in 80 by 160 aluminium extrusion, and this will come up. But it does pay to shop around, because you know it's not cheap. You know, this is like $250 worth, because we're going, you know, sort of 4 foot. And it's actually priced and sold by the 4-inch length. Okay, weird measurement, but there you go. So that's on the way. I've actually bought that yesterday. I ordered that, but it's going to, you know, take some weeks to get here. I did try to buy that locally in Australia, but it worked out they wanted about $80 more than what I could get it from overseas. So, you know, what do you do? Unfortunate, but there you go. Next thing on the market, so next thing on the agenda after the gantry. Oh, look, the reason why I wanted to cut down weight will become apparent in a minute, because you know I'd be loading the gantry up the 2.2 kilowatt spindle and all this, that, and the other, which is 3 horsepower, and you know the weight was just going up, so I had to get something to cut down on the weight. I'm trying to make the gantry weight less than 30 kilograms, which is about 70 pounds. Okay, yeah, they start to get a bit heavy. Okay, so this is what I've elected to use. Now I've chosen these on an engineering, looking at it as an engineer, what energy is required, what torque is required, an output from a motor to do the job, and do the job well, with some power left up its sleeve. And that is NEMA 24's high torque output. Now, these are a DC motor. Now their service operational power output is 3.5 Newton meters, and it's got a big shaft on it. Okay, this is a 10 millimeter shaft to take the additional torque. That's very important. It's a D shape as well. It's got a flat on it, so it gives you a better chance of clamping it. Now, with essentially it's a DC motor with 4 windings in it. Now the thing is with DC motors, although they're rated to work at that torque and output at 36 volt, well, I'm going to be running the whole system at 48 volt. That means on peak periods of time, not full time, just peak periods of time, this is capable of managing 4 Newton meters. Only for a few seconds. That's all you need it for, just to change direction rapidly. So that's why I've chosen these. Now I will show you. These are the NEMA. Now NEMA 23s just probably wouldn't be man enough. Okay, now this is a NEMA 24. Okay, this particular one is 3 Newton meters. So you can see it's got an 8mm shaft on it. All right, and it's, how long is it? That's 85mm long. Okay, that one is much longer. It's 110, I believe. So in other words, it's got the coil packs in here much longer. Okay, so it gives out greater torque, hence bigger shaft to handle the torque. Like I say, NEMA 23s wouldn't be able to, sort of, I don't think, sort of be man enough for that job. So that's that. Now to support these at 48 volts and high ampage output, I am putting in 2 of these. Now these are 400 watt, 48 volt power supplies. So I'm putting 2 of those in, so each one will power 2 stepper motors. Okay, not really an awful lot can be said of that. Pretty standard switching unit. It'll do 150, 110, 110 volt, 240, 230 volt. Of course, we're in Australia, 230. And incidentally too, I will do a special video when I'm building this on every single wire, okay, of how to connect it up and where. All right. I have in the last build, I've sort of relied on previous videos that I've done on builds where I've shown how to connect things up, and I think people are getting a little confused or lost. So I will do a dedicated video on the wiring of this unit. I will also do a dedicated video of how to set up the VFD for the spindle. Okay, that's very important to set the parameters correctly, because you'll blow up your new spindle or your VFD or both. Okay, spindle, 3 horsepower. Now this is the actual one that I've ordered. It's on the way. Don't know when it's going to get here due to COVID, but it's on its way. I've elected to go air-cooled this time because I had a couple of problems with the last 2 rotors that I had, bought ones, ready-made, with electrical leaks in the water system, and causing all sorts of blooming problems. So I thought, okay, so I've done a lot of research on air-cooled ones, so I picked the best one. Now you will notice when if you go searching around for air-cooled spindles, they will tell you that maximum RPM output is 18,000 RPM. Well, I don't want that. I want 24,000 RPM because I do a lot of 3D carving, and it requires 24,000 RPM with you know, sort of a 1 millimeter ball mill and tapered ball mill, and so 18,000 just isn't. It's okay, but not for me. So I'll tell you a little trick with these. Air-cooled, good quality air-cooled, is order them with ceramic bearings. It is the ceramic bearings in these that allows them to go all the way up to 24,000 and above. Normal steel bearings just won't hack it over a long period of time, and they're not easy to change the bearings. It's like turbos on it, on your car. You've got to press them apart and all sorts of things. So ceramic bearings, 4 bearing unit you require. So that's what you're paying the money for. They're not cheap, okay? You know, if you're going to get a cheap one off eBay, you know, and pay $200 for it, I don't know how long it's going to last you, tell you the truth. So if you want something to last you a good number of years, everything wears out over time. But if you want a good one that's going to last you, that's going to be reliable, you know, you need to go for something less. And all the information of parts, and again drawings and everything, will be available eventually on my Patron pages. Okay, so what else can I say about that? Oh, this. Something else is very special about this. This is not captured in a, you know, sort of adjustable slide. This has the whole body of this has this solid fixture. You know, the body is the fixture that you bolt directly to your Z-axis drive plate. Okay. So you know, I'm not going to have to sort of unclamp and slide down. You know, this is going to be in one position. I rarely moved mine up or down on my other big 6012. So this is what I've gone for. So it's permanent fixture, but I'm going to have a series of holes that if I need to do a special job where I do need it further down or further up, I can actually move this physically up or down. You know, a couple of inches, 2-3 inches, whatever. So yeah, this is what I'm now recommending, providing it has 4 ceramic ball races and you know, this type of body then as well. And that will give you then 24,000 RPM. So on to the next thing. And what I've elected, I've had a lot of people question, oh, how am I going to maintain the rigidity? Well, easy answer is I'm not going to build it of wood. That's the easy answer. I mean, look, you can build the lower section of wood if you like. But if you want a CNC router, especially of this caliber where it's going to take half a sheet, you don't want the thing moving around, you know, and they will. You know, if you use something like extruded aluminium bolted together, it still can move. You know, so what I'm doing, RHS, square box section, 4" by 4", 3 to 4 millimeter in thickness. I'm lucky I can go to the local stockist because I know them, and I can pick a length and make sure it's dead straight. So what I intend to do is have, either I might go slightly bigger, but at the moment it's looking like 4" by 4" or 100mm by 100mm by 4mm thickness. 2 of these rails for the Y, and then probably 2" by 4", which is the one sat next to it there, for cross sections, of which there's going to, I'm not sure it's going to be 4 or 5, and it's going to be welded. Now I'm going to have to make a jig up to hold it absolutely square, and I'll show you. I've got a MIG and a stick welder over there, which I haven't used for about 5 years, I think. But look, I'll show you how to do it. I'll even teach you how to weld if you want. So if you want to let me know in the comments section. I mean, the trick is welding it up. You hold it solidly in a jig, all right, and you tack weld it up first, and then you don't fully weld a complete joint in one area first. You weld partly here, then you move on to the next one, partly weld it, and go all the way around the unit. Okay, partly weld, partly weld, partly weld, all the way around, and then check it to make sure everything's still in line, and then you come back and you weld a bit more on here, and you do it, you do it gradually. You just don't sort of go straight into it and weld this joint fully up, and then go to the next one and weld that joint fully up, and so on and so forth, because by the time you get right the way around, you find that it's twisted as it cools. So you've got to be sort of quite careful about it. But if it does twist on you, all is not lost, because you can actually straighten it out. And a lot of people sort of weld the whole thing up, all right, including the legs and bracing and everything, weld it all up, then check it to find out, it's 1/4 of an inch out of whack, and then it's very hard. You've got to go cutting welds through and putting it back and then re-welding it. You can make a mess of it. Anyway, so that is what we're going to do for the large rotor. I will put out more information as I get parts delivered, and it'll be good. One thing I want to ask you guys, because I don't want to do something that you don't want to see. So what I'd like to, a little bit of a poll, I suppose, but if you could just write a very quick message in the comment section below, or on my Patron pages, or wherever you want to put them so I can see them, and that is, what do you want it operating with? Do you want Mach 3, Mach 4, or do you want another SMC controller? Just let me know. And look, whatever you guys decide you want to see, that's what I'll do, because I really don't mind. Okay, so there we go. I hope, I know I'm not going to satisfy everybody, and I'm sorry about the guys who wanted the mill first, and I'm definitely going to do it, but there's more people out there, like I say, 60-40 split, want a router. So, I put it out there, what you want, and you've let me know. So, there it is. and you know, I've made a few adjustments to fall in line with what you guys are asking for. But I would say that the milling machine that will be NEMA 34s, and they will be servo drives. All right, so we've got the best of both worlds now, and it's going to, you know, both projects are going to take me a year, just over a year maybe, to carry out, because there's only me here to it. Okay, and look, you know, the MIDI CNC router won't be forgotten. I'll still be doing projects with that, and I do hear to the laser boys. I've got some more laser stuff in the next few weeks, actually, and of course Carveco. But I'm going to have to sort of do a bit of a rotation of videos, you know, what we see. So anyway, please like and subscribe, and if you would like to support this channel, because it is the patrons behind this channel that allow me to do things like this. It's the patrons that are actually allowing me to do this. So if you'd like to become a patron, the information will be down below this video in the description section, and I would be really grateful. It gets a bit hard sometimes, I can tell you, because I don't know whether you are aware, but a lot of the big advertising guys pulled out from YouTube, and it's very limited now, the revenue. So I think everybody on, or most people on YouTube are struggling. So, you know, if you don't help me out, try and help someone else out, because I'm sure they'd appreciate it. Not quite sure what the next video is going to be. May well be a laser video, actually. I'll have to have a look what I've got slated for this weekend, but I hope this one for the moment will suffice, and I hope you've enjoyed what you see. And don't forget, let me know what you want, Mark 3, Mark 4, or another SMC. Okay, so thank you for joining me, and thank you for watching the video, and it's bye for now.